Okay, so this is Quideo number 6, and for part A, they ask us to use a 99% confidence interval, which means we are going to use pants. And to do that, we first use P for parameter. The parameter of interest in this problem is the mean wait time for patients with heart attack symptoms depending on transportation type. And you can see it kind of says that right there where I marked parameter. And then for A, that stands for assumptions, it states that it's a simple random sample. They're not simple, but it just says random in the problem. And both sample sizes are over 40, so the central limit theorem applies, which means that there are no outliers and there is a normal distribution. For N, it is a 2-sample Z interval, and we can figure that out because it states the standard deviation of wait times, but not for the entire population. And then for T for test, this is the normal formula for a 2-sample T interval. And when you plug all the numbers in from this is what you get. And you end up with negative 4.3177 and negative 2.2023. And to find degrees of freedom, which that's important with a t-test, you do n-1, and you have 77 and 73, which those are the sample sizes. Subtract 1, you get 76 and 72. Now the problem doesn't ask for that, but that's also important. And also, this is the margin of error, 0.7777. And since these are both negative, we know that the time is going to go down. And then for S, that's where we state our conclusion. So I put, based on this sample, we can say with 99% confidence that the true difference in the population means lies between negative 4.32 and 0.20 minutes. And we are 99% sure that the mean wait time for ambulances is shorter than self-transportation by between 0.2023 and 4.3177 minutes, which, since we did a 99% confidence interval, we are 99% confident. For part B, they ask if we think the mean, or if they think the difference in mean wait times is statistically significant. I said yes, and the reason for that is because 0 does not lie in the 99% confidence interval, which is negative 4.32 and negative 0.20. Obviously 0 does not lie in either of those. And we can reject alpha at 0.01, which we would use that because this could be a life or death situation since it deals with ambulances and stuff. That's pretty serious. So we'd always use alpha equals 0.01. And the hypothesis would be mu1 minus mu2 equals 0 for the actual, which is mu1 minus mu2 does not equal 0, which you can see from the problem. And that's all for this video. Also, one other thing I forgot to say is, for this you could use phantoms, and also you would need to make sure you use a one-tailed test instead of two-tailed, because you're finding out if it does not equal instead of less than or greater than. Yeah.